In this course on Node.js security, we will delve into the top 10 best practices to secure your Node.js applications. These practices are essential for anyone involved in developing or managing Node.js applications. They will help you mitigate common vulnerabilities and ensure a robust defense against potential security threats. Let's get started. This slide focuses on the target audience for this course. It is designed for three main groups: developers, security experts, and DevOps engineers. Developers will gain insights into incorporating security best practices while coding in Node.js. Security experts will find this course useful for understanding specific vulnerabilities associated with Node.js and how to mitigate them. DevOps engineers can use the knowledge from this course to ensure that their deployment pipelines maintain high security standards for Node.js applications. Each of these roles plays a crucial part in maintaining a secure and robust application environment. The purpose of this course is to equip developers with the best practices for Node.js security, helping them mitigate potential vulnerabilities. Our goal is to enable you to create robust and secure Node.js applications. By understanding and implementing these security measures, you'll be better prepared to safeguard your applications against common threats and ensure their resilient performance. This slide provides an introduction to Node.js security, outlining its significance. We will start by understanding the basics of Node.js, a JavaScript runtime built on Chrome's V8 engine that enables scalable web application development. The importance of security in Node.js stems from its vast open-source ecosystem, which introduces potential vulnerabilities, especially from third-party packages. With the increasing number of security threats, it becomes imperative to prioritize and implement robust security measures in Node.js applications to ensure their resilience. Node.js is a JavaScript runtime built on Chrome's V8 engine. This allows developers to build scalable web applications by leveraging an event-driven, non-blocking I/O architecture. Essentially, Node.js operates on a single thread but can manage a significant number of concurrent connections efficiently. Key features of Node.js include 1. Non-blocking I/O. This feature ensures that operations such as reading from a database or file system do not block other operations from executing, which is crucial for building high-performance, real-time applications. 2. Event-driven architecture. In Node.js, everything that can happen within a process is an event. This architecture allows the application to be more responsive due to its ability to handle numerous events simultaneously. Single-threaded but concurrent. Although Node.js operates on a single thread using something known as the event loop, it can effectively manage multiple operations concurrently, which is ideal for applications with many I/O operations, like web servers. These elements combined make Node.js a powerful tool for modern web development, emphasizing efficiency and performance in handling numerous client requests. On the current slide, we delve into the critical reasons why it's essential to secure your Node.js applications. According to Snike's State of Open Source Security report, the average project contains 49 vulnerabilities stemming from 79 direct dependencies. This highlights a significant security risk, particularly given the prevalence of open source packages in typical Node.js projects. Among the security risks, malicious actors can exploit vulnerabilities within these dependencies to gain unauthorized access. The interconnected nature of dependency chains further increases the potential attack surface, making it easier for hackers to infiltrate your system. Effective security measures are vital to mitigate these risks and protect your application and data from potential breaches. Understanding these inherent vulnerabilities and their potential impact is the first step towards securing your Node.js environment. Let's take a closer look at the top security vulnerabilities commonly encountered in Node.js applications. These are critical risks that every developer should be aware of and actively protect against. First, we have cross-site scripting, XSS, where attackers inject malicious scripts into web pages viewed by other users. This can lead to stolen cookies, session tokens, and even user information. Next is cross-site request forgery, CSRF, a tactic where a malicious site tricks a user's browser into performing unwanted actions on a different site where the user is authenticated. Code injection is another severe risk where attackers introduce malicious code into your application, leading to potential control over your server and data exfiltration. Distributed denial of service, DDoS attacks aim to overwhelm your server with excessive requests, causing service outages and disruption to legitimate users. Lastly, we have regular expression denial of service, RDoS attacks. These usually occur when an attacker crafts input that causes a regular expression to take excessive amounts of time to process, leading to performance degradation or application crashes. These vulnerabilities highlight the importance of thorough security practices in Node.js development. The cross-site scripting, or XSS, happens when user input is not properly validated, allowing malicious JavaScript to be injected into web pages. The impact of XSS can be severe as it grants attackers access to cookies, tokens, and other sensitive user information. For instance, an attacker might inject a script like script alert hacked script, which would execute whenever the compromised web page is viewed. This can lead to unauthorized actions being performed on behalf of the user without their knowledge. Cross-site request forgery, or CSRF, involves an attacker tricking an authenticated user into executing unwanted actions on a web application where the user is currently authenticated. This typically happens when malicious code is executed under the guise of seemingly trustworthy HTML elements, such as links or forms. The impact of CSRF can be severe, allowing attackers to change user settings or complete transactions without the user's knowledge or consent. This type of attack can lead to unauthorized changes and potentially compromise the security of user data and the integrity of the application. Code injection is a critical security vulnerability that arises from flaws in input validation. Essentially, attackers exploit these flaws to inject malicious code into a program, which can have devastating consequences. The impact of a successful code injection attack can be severe, leading to data theft or even the infection of the system with malware. For instance, an attacker could execute a database command like drop table users, which would delete an entire table of user data from a database. This underscores the importance of rigorous input validation practices to safeguard against such vulnerabilities. By ensuring that all inputs are properly sanitized and validated, you can significantly mitigate the risk of code injection attacks. In summary, proper input validation is essential to prevent attackers from injecting harmful code into your systems. Distributed denial of service, or DDoS, is an attack method where the attacker floods the server with a massive amount of traffic, overwhelming the system. This can lead to significant service interruptions and outages, rendering the service unavailable to legitimate users. For example, an HTTP handling bug in Node.js versions 4 through 4.1 can be exploited to carry out a DDoS attack. This kind of vulnerability is highly disruptive and can cause severe operational and financial damage to an organization. Regular expression denial of service, or RDoS, occurs when attackers craft complex regex patterns that cause a program to evaluate very slowly. This, in turn, consumes excessive resources, leading to service degradation, potential halts, and ultimately a denial of service. An example of such a pattern might be something like AB1000N, which takes a significant amount of time and resources for the server to process. This vulnerability can be particularly problematic because it exploits weaknesses in how regular expressions are handled, potentially bringing down services that depend on them. Addressing these vulnerabilities is crucial to maintaining the stability and security of your applications. In this section, we will discuss the best practices to secure Node.js applications. There are several key areas to focus on. 1. Logging and monitoring. Implement thorough logging and monitoring to gain insights into your application's behavior and detect any suspicious activities. 2. Strong authentication policies. Use robust authentication mechanisms to ensure that only authorized users have access to your application. 3. Avoid blocking event loop. Ensure that none of your application's operations block the event loop, as this can significantly degrade performance. 4. Safe error handling. Implement safe error handling techniques to prevent leaking sensitive information through error messages. 5. Limit request sizes. Control the size of incoming requests to protect your application from payload-based denial of service attacks. 6. Validate user inputs. Always validate user inputs to prevent injection attacks and ensure that the input data meets your application's requirements. 7. Ensure secure deserialization. Use secure deserialization methods to prevent remote code execution and other security vulnerabilities. 8. Use security linters and SAST tools. Employ static analysis security testing, SAST tools, and security linters to identify and fix vulnerabilities in your code during the development process. 9. Run as non-root user. Operating your application with the least privileges necessary can minimize the impact of any potential security breaches. Implementing these best practices will significantly strengthen the security posture of your Node.js applications and help protect them against potential threats. For this slide, we'll focus on logging and monitoring. The purpose of logging and monitoring is to gain insights into your application's behavior and to detect any suspicious activities effectively. By implementing comprehensive logging practices, you can not only understand how your application is performing, but also identify unusual patterns that could indicate security issues. Some recommended tools for logging and monitoring in Node.js are Bunyan and toobusy-js. Bunyan is a simple and fast JSON logging library that is efficient for both development and production environments. It helps in creating structured logs that can be easily parsed and analyzed. To use Bunyan, you can install it with the command npm install Bunyan. toobusy-js is another useful tool that allows you to monitor the event loop. It helps in identifying when your application is under heavy load, which can be an indicator of potential bottlenecks or an attack like a DDoS. It helps you keep your application responsive by providing a mechanism to automatically suspend processing when the event loop becomes too busy. You can install toobusy-js using the command npm install toobusy-js. By incorporating these tools, you'll be better equipped to maintain the stability and security of your Node.js applications through effective logging and monitoring. In this slide, we focus on enforcing strong authentication policies, which are crucial for ensuring the security of any application. We have several important guidelines. Require multi-factor authentication. This adds an extra layer of security beyond just passwords, making it much harder for unauthorized users to gain access. Use Scrypt or Bcrypt libraries. These libraries are designed for secure hashing of passwords, providing a robust defense against brute force attacks. Implement consistent session handling policies. Ensuring consistency in session management can prevent various types of session-related vulnerabilities. Require strong passwords. Enforcing strong password criteria, such as a mix of characters, numbers, and symbols, reduces the risk of compromised accounts. Limit failed login attempts. Implementing a limit on failed login attempts helps in mitigating brute force attack risks by locking out accounts or escalating security checks. Following these guidelines ensures that your application maintains a high level of security, protecting both your data and your users. On this slide, we're focusing on strategies to avoid blocking the event loop in your JavaScript applications. Blocking the event loop can severely impact the performance and responsiveness of your application. Here are some effective strategies to prevent this. Firstly, ensure to use quick JavaScript callbacks. The quicker your callback functions execute, the less time they spend blocking the event loop. Secondly, aim to reduce the complexity of your callbacks. The simpler and more efficient your callbacks are, the better your application's performance will be. Next, it's essential to bound and reject lengthy inputs. By limiting the size and complexity of the inputs your application processes, you minimize the risk of blocking operations. Furthermore, avoid using synchronous APIs. Synchronous operations hold up the event loop until the operation completes, which can block other useful work from happening. Instead, opt for asynchronous APIs that allow other processes to run concurrently. Here's a concrete example to illustrate this concept. Instead of using a synchronous file read operation, you can use an asynchronous one. JavaScript fs.read file.txt if console.log data. This approach ensures that the file read operation does not block the event loop, allowing your application to remain responsive. By incorporating these strategies, you can significantly improve the efficiency and user experience of your JavaScript applications. When it comes to safe error handling in Node.js, there are a few best practices you should follow to maintain a robust and stable application. Firstly, using promise libraries or the async await syntax can greatly simplify error handling in asynchronous code. By avoiding custom error handling, you ensure consistency and reduce potential pitfalls. Centralizing your error handling logic is also crucial. This means having a centralized place where all errors are caught and appropriately handled, which simplifies maintenance and debugging. Regularly testing error flows will help you catch issues early before they escalate in a production environment. Finally, employing process management tools like PM2 ensures your application remains resilient. PM2 can restart your application on crashes or unhandled errors, helping you avoid downtime. For example, install PM2 globally using npm with npm install PM2g, and start your app with PM2 start app.js. This ensures your app is managed and monitored effectively. On this slide, we'll discuss the importance of not sending unnecessary information to the front end. Ensuring that only essential data is transmitted helps to protect sensitive information and optimize performance. You should filter the data you send, making sure it is minimal and specific to the front-end needs. For example, if you have a user object but only need to send the name, structure your response like this. Send user.name. This practice reduces the risk of inadvertently exposing sensitive data and helps in maintaining a cleaner and more efficient API response. On this slide, we'll be discussing the importance of limiting request sizes in your applications. The primary purpose of limiting request sizes is to prevent distributed denial of service (DDoS) attacks, which aim to overwhelm your server with large or numerous requests, making it unavailable to legitimate users. To effectively limit request sizes, you can configure the limit option in the body parser package. This package allows you to parse incoming request bodies in a middleware before your handlers, making it easy to control the payload size. Here's a simple method to implement it. Use the bodyparser.json function with a specified limit. For example, setting a limit of 1 megabyte would look like this: JavaScript app.use bodyparser.json, limit 1 MB. Additionally, consider using reverse proxies or express middleware as another layer of protection. These tools can monitor and restrict incoming traffic to your server, providing an extra line of defense against excessively large requests. By implementing these methods, you can ensure that your server remains resilient against potential attacks, maintaining its performance and availability for your actual users. In this slide, we are focusing on the importance of validating user input to enhance the security of our web applications. The key tools you can use for this purpose include DOM Purify, Express Validator, and various XSS filters. To incorporate these into your project, you need to install them first. You can do this using npm with the following commands: npm install DOM Purify, npm install Express Validator. For instance, using Express Validator, you can implement input validation in your express.js application. Here's an example. JavaScript const check validation result equals require Express Validator. App.post submit check usernames alphanumeric.is length min5.req rec res const errors validation result req if return res.status 400 json errors.array. In this example, we make sure that the username field contains only alphanumeric characters and that it has a minimum length of 5 characters. We also trim any extra spaces from the input. If there are any validation errors, the request is rejected and a response is sent with the status code 400, along with a JSON object detailing the errors. This proactive approach significantly reduces the risk of various attacks such as SQL injections, script injections, and other malicious user inputs. When dealing with deserialized data, it's crucial to ensure its integrity and authenticity. This involves using mechanisms such as integrity checks and authentication to confirm the data hasn't been tampered with. Additionally, make sure that any deserialized data is properly sanitized to prevent the inclusion of malicious payloads. There are various options to support secure deserialization, including anti-CSRF tokens and same-site flags for cookies, which help mitigate cross-site request forgery attacks. Custom headers can also be used to provide additional security layers. Here's an example using anti-CSRF protection. JavaScript app.csrf cookie true. This middleware ensures that any incoming requests contain a valid anti-CSRF token, which helps to confirm the authenticity of the request and thus safeguard your application from CSRF attacks. To continue ensuring the security of your Node.js applications, it's essential to use security linters and static application security testing (SAST) tools. These tools can help you automatically detect vulnerabilities and enforce security best practices during code development. Some of the recommended tools include ESLint plugin Node Security and Snike Code. To integrate and use these tools, you can install them using the following commands. For ESLint plugin Node Security, run bash npm install ESLint plugin Node Security. For Snake Code, you can globally install Snake and run security tests using bash npm install Snake global Snake test. By incorporating these tools into your development workflow, you can proactively identify and address potential security issues, making your applications more robust and secure. On this slide, we focus on running your Node.js application as a non-root user. This practice is crucial for minimizing the impact of any potential compromises. Let's look at a practical example. First, we create a new user named Node.js user by running the command sudo adduser Node.js user. Next, we change the ownership of your Node.js application directory to this new user, sudo chown r Node.js user /path/app. Finally, switch to the newly created user, sudo Node.js user. By operating your Node.js application under a non-root user, you significantly reduce the risk that an attacker could leverage root privileges if they gain access. This is an essential step in fortifying the security of your Node.js projects. In summary, let's recap the key points we've covered regarding Node.js security. First, we emphasize the importance of Node.js security and how critical it is to protect our applications. We explored some common vulnerabilities that can pose risks to your projects. Additionally, we discussed best practices and tools that can help mitigate these security threats. As for the next steps, you should implement the guidelines we discussed into your own Node.js projects. It's also crucial to regularly update your dependencies and continuously monitor for any newly discovered vulnerabilities. This proactive approach will help ensure that your applications remain secure over time. Now, let's look at some valuable references and resources to help you continue your journey in enhancing Node.js security. Firstly, the Node.js Security Best Practices is an essential resource that provides comprehensive guidelines and up-to-date information on securing your Node.js applications. Additionally, the official Node.js documentation is a reliable source for understanding core features, updates, and best practices straight from the Node.js maintainers. Make sure to leverage these resources to stay informed and implement the best strategies in your projects effectively. Use them to deepen your knowledge and keep your applications secure. Thank you for taking the time to go through this course. If you found the material helpful, please leave a like and share your thoughts in the comments section below. Your feedback is invaluable for improving future courses. Don't forget to subscribe to the channel to stay updated on new content. Share the knowledge by passing it along to your friends and colleagues. Your support helps us create more quality content. If you found the previous content valuable, please show your support by leaving a like. Your feedback is important to us. Feel free to comment below with any thoughts or questions you might have. Don't forget to subscribe to the channel to stay updated with our latest content. Also, consider sharing this course with your friends and colleagues who may benefit from it.